Hey everybody, this is another video in my atomic structure and nuclide symbols series, and finally we are going to do some sample problems and put it all together, and we will be completing a chart problem. So let's take a look at our first sample. So these are fairly straightforward sample problems where we will be given the nuclide symbol, maybe with an atomic symbol or not. In this case, there's no atomic symbol in the middle. Let's take this and answer the question. So we want to go here and we want to know the number of protons. The number of protons is probably the easiest thing to figure out because that's just this number down here in the corner. The number of neutrons is a little more challenging to figure out, but not that much more challenging, because what we know is that the number of neutrons is related to this number here, the mass number, and we know that the number of protons plus the number of neutrons gives us that. So actually, if we just set up a math problem here and do some column math like we did back in 3rd or 4th grade and just subtract these two, we get the number of neutrons here is 17. Now lastly, we have to figure out the number of electrons, and so we need to use the charge. And again, this one is maybe the most challenging of them all. So we know that the number of protons can't change. If we change the number of protons, it changes the element. So in order to determine the number of electrons, we have to compare. This is 2 minus, which means there are 2 extra electrons compared to the number of protons. So those 2 extra electrons is going to translate into having 18 electrons. Okay, so now we can do the same thing here, and if we're going to do the number of protons, the number of protons is 38. The number of neutrons, again, if we take this and subtract, we get that the number of neutrons is equal to 50, and the number of electrons here, now we have to figure out. So here we know that there are 2 extra protons, and so since we can't change the number of protons, we know that there are 2 extra, which means there are 2 more protons than there are electrons, so this means that this is 36 electrons. The last thing that this question asks us to do is to give the nuclide name of this. Okay, so let's make a little room. The nuclide name is going to, we would need a periodic table, and we find element number 16, that's sulfur, and then we put a hyphen and then the mass number. Okay, then we can do the same thing over here. Element number 38 is strontium, and its mass number is 88, so it would be strontium 88. Now let's do a chart problem. Here we have all the stuff going on where we are going to try to figure out all of this information based on the minimal information given in the problem. And this should be fairly straightforward, I hope, now that we've gotten all the systems down and we figured it all out. So we need a periodic table. And so if we're going to determine the number of protons in sodium, we look at the periodic table, and that's going to give us a number of protons as 11. The atomic number and the number of protons is always the same. Okay, the mass number is the number of protons and neutrons added together. So that's going to give you a mass number of 34. And the charge, remember, the charge is a comparison between the number of protons and the number of electrons. So we compare and we see that there's 1 more proton, so that's a 1 plus. And then we do we give it the nuclide name, and so this is going to be sodium hyphen 34. Okay, we probably also need to finish the nuclide symbol, and this may be the first nuclide symbol that we have done through this whole series. But in the bottom, remember, is is the atomic number. At the top is the mass number. In the top right-hand side is the charge, 1 plus. Okay. So here in the second column, we don't know the element, but we do know the number of protons. So remember, the number of protons is equal to the atomic number. Then we can go to the periodic table, and we see that this is element symbol V, vanadium. Okay, and then the number of neutrons here we don't have, but we can determine the number of neutrons because the number of protons plus the number of neutrons equals 50. So that must be 27. 23 and 27 is 50. And again, if we're going to determine the charge, we are going to compare the number of protons to the number of electrons here. And we'll notice again that there are extra protons making this charge 3 plus. If we're going to write the nuclide name, we would write this as vanadium -50. We should fill out the rest of the nuclide symbol. Down here is going to be a 23. Up at the top corner is going to be a 50. And to the right is going to be the charge 3 plus. Okay. So now the next column here, we're going to use all this information to determine the blanks. And so again, we know the number of protons and number of neutrons. So the atomic number is just the number of protons, and the mass number is going to be those two added together, which is 17. And then the number of electrons we can get from the charge. When we compare the number of protons to the number of electrons, we will get 2 minus. That means there's 2 extra electrons, so that means that there are 10 electrons. We look at the periodic table. That gives us a name of oxygen. Its mass number is 17, so that's oxygen 17. And now we can write the nuclide symbol, O, with an 8 down there and a 17 in the upper left-hand corner with a 2 minus charge here. Now, the last one gives us a nuclide name and the charge and nothing else. So let's get at it. This is the fun part. Okay, cobalt-60. We know that cobalt, from looking at the periodic table, has 27 protons. That is also its atomic number. Okay, and we also know that 60 is the mass number of this particular nuclide. So I'm going to put a 60 there. The number of neutrons is determined from the mass number and the number of protons. We know that this plus this should give us this. So this is going to be 33. And the number of electrons can be determined from the charge and the number of protons. We know by comparing the number of protons to the number of electrons, that's going to give us the charge. So when we compare that, we should get 4 plus. So that means there are 4 extra protons. And so that means there are 23 electrons. So now if we're going to write the nuclide symbol for this, we get CO, and then the charge here is 4 plus. The number in the upper left-hand corner is the mass number, that's 60, and the number in the lower left is the atomic number. Okay, so there's your sample problems on how to do a chart problem and determine nuclide symbols. Have a great day.